Another research project at ASU is using portable DNA sequencing to better understand how the overuse of antibiotics can lead to superbugs. Joining us now is Lee Voth-Geddert from ASU's Biodesign Center for Health Through Microbiomes. Welcome to Arizona Horizon. You betcha. All right, let's start with some semantic. What is a superbug?
Yeah, so a superbug is really kind of thinking about a bacteria that has gained the ability to evade most, if not all, our antibiotics that we have available to us. So if we get that specific bug that would be a pathogen, then we don't have the antibiotics that we could take to be able to fight that infection.
How common are these superbugs?
They're getting more and more common.
Yeah.
There's degrees. We kind of have a scale of severity, and CDC actually has kind of a list of bugs that we're tracking to make sure that we're identifying the trends. If they're going in bad directions, we know we can kind of shift or potentially like roll out different policies for how we might kind of handle antibiotic usage.
And antibiotic usage, that is the key here. The more antibiotics you use, it seems like the superbugs recognize it and say we're going to develop into something else?
Yeah, so really it's the kind of the pressures of these antibiotics. And so, to take an example of the human body, let's say we have 100 bacteria in our human body. We take an antibiotic that takes care of 95 of them, but we still have 5 that might be just a little bit more resistant to the antibiotic that we just took. And now those are still there when we stop taking the antibiotic, and they have room to grow. And so that's kind of how that pressure of the antibiotic forces growth of new resistant strains.
And this is a danger to humans, animals as well, a danger to the environment as well?
Yeah, so we think about the environment as where it kind of circulates, and we think about the health of the animals and the humans. So we really kind of think about the One Health aspect of this. We're really focused on humans, but we're all connected in this really complicated systems of systems.
All right, now your research is in tandem, I'm reading here, from the UN and Indonesia, and it basically involves, what, a handheld DNA device?
Yeah, so if you're okay with a little show and tell,
please.
I brought the device here. So literally, this is kind of trying to take our kind of gold standard science in our laboratories and get it into hands on people in the field, the frontline workers that we have. And so literally, it looks like a stapler, to be honest with you. But we just plug it into a laptop, and we're able to actually do DNA sequencing in the field and be able to kind of take what we have in terms of the laboratories and bring it to people that can use that information.
Okay, but when what do you do? Do you stick it in water? Do you put it in the air? What do you do?
Great question. So we were able to we have our little pipettes and all the kind of nerdy stuff here, and we take it and we take our sample and then we put it into the DNA sequencing device to see what type of DNA is in that device or in that sample that we took. So it could be water, it could be poop, it could be waste out of a slaughterhouse.
Yes. Well, I saw that you were looking at slaughterhouse, like 6 chicken slaughterhouses in Indonesia, and they have their own antibiotic surveillance system. Is that true?
Yeah, and Indonesia is doing a pretty good job in terms of rolling it out. It's tricky. So Indonesia has like 14,000 different islands. So in terms of thinking about a national surveillance system, that's a tricky task. And so things like this, where we can decentralize the monitoring systems, it can be a really powerful tool. But that can apply here at home, too.
Right. And you can tell when some of this bad stuff is going into waterways, rivers, and such?
Yeah, so our core focus is trying to identify those kind of control points, the points where things in these different systems all convalesce. So think about a chicken slaughterhouse being kind of that point of animals coming in, the food going out to humans, and that waste going into the environment. So that's a really tantalizing kind of place to be able to monitor and potentially control kind of the resistance mechanisms that might get into the environment and spread.
I tell you what, it sounds like before this thing came along, I mean, good luck against these superbugs. That must be difficult to control these things.
Yeah, we had our methods that we were able to use kind of in the labs, but it took fancy labs to be able to do that.
Yeah.
And so the more we can get, simpler tools into the hands of folks that are kind of on the front lines, the better.
Can be used with farms. What about these wet markets that we all grew so familiar with regarding COVID? Can be used there as well?
Yep, absolutely. Yeah, anything you need sequenced, you can do it with this device, which makes it so powerful in terms of being able to see kind of new information that we weren't being able to before.
Bird flu?
Yep, they're actually working on that now in Indonesia and across the board. CDC is working on this as well.
Okay, so the whole idea here is to stop the spread of these superbugs. Is there hope? I mean, it sounds like such a daunting task with all these things around the world. This will help. will it help enough?
Yeah, so it's one part of the solution, right? So we
Yes.
need kind of these, novel techniques, and we don't just, they're not just novel, they're necessary. So we have to be able to kind of take, kind of these new and emerging things and be able to implement them in the system. So there's a couple parts to it. One is thinking about new antibiotics, and the other is thinking about stewardship for the antibiotics that we do have to make sure we can extend the life of their effectiveness.
Okay, and DNA sequencing, obviously a big deal. Portable DNA sequencing sounds like a really big deal. Can it be used in other theaters?
Absolutely, yeah. And so other theaters being, geography, absolutely, that's what we're working on. Other theaters being different types of samples, different types you talked about, the wet markets, or even kind of, ag systems here, or even hospitals and monitoring resistance in those. All the different mediums, can really benefit.
Is there, last question here,
Yeah.
is there a security concern with this?
There is certainly, because we're focused on, kind of the water or poo or those types of things, we're a little less concerned about that. We have our kind of protocols in place to manage that type of data. But as that scales in terms of the quantity of data that we have, we'll have to certainly, we'll continue to take that into account.
Yeah, make sure you don't have individual DNA sequencing out there.
We're focused on the bacteria and the superbugs.
Yeah, among the mass. All right,
Yep.
Lee Voth-Gettert, again, ASU and the portables. Hold that thing up one more time. Look at that thing. That's unbelievable. Congratulations on that. Good work. Thank you for joining us and sharing your story.
Appreciate it.
You betcha.